Okay, so today we're talking about special right triangles, which are right triangles that have special different properties. So if we start with a square and we cut it in half diagonally, so we draw this line here. What does it do to the two angles? These two angles are bisected, and these are all 45 degrees. So if we have this triangle, which is this square already cut in half, that's 45 degrees, and this is 45 degrees. So these two sides, we could call them x. It doesn't really matter what their length is, but these are both congruent and are called x. This side, if we were to use Pythagorean theorem, we could find out that this side will always be x times the square root of 2. So whatever these side lengths are, the hypotenuse, this longest side, is always going to be one of the side lengths, which in this case are the same, times the square root of 2. So if we talk about the ratio of the side lengths, which we talked about with similar figures, would be 1 to 1 to square root of 2. As we go on to these next examples here, we can show a little bit about how we get x or x if we have the hypotenuse. So in this case, this x, we know that one side is 6, so we know that the hypotenuse has to be the leg times the square root of 2. So x in this case will equal 6 square root 2. For number 2 here, we're still looking for the hypotenuse, and we have these two sides. So because this is 9 square root 2, 9 square root 2 times the square root of 2 will get us x equals 18. So if we already have a square root 2 on the sides, we can multiply by square root 2 again, so then it's 9 times 2, which gets us 18. In this case, for number 3, we know the hypotenuse is 5 square root 2, so then these two legs, which are both x, have to be 5. And our final one here, with 18 being on here, we can look back at our previous one. We knew the hypotenuse is 18 here with our 45, 45, 90 triangle. So then x has to be 9 square root 2. But even if we didn't know what it was from up here, we can take this number, divide it by 2, and then put square root 2 after it, and that will get us that leg. The next kind of special right triangles we're talking about are 30, 60, 90 triangles. So we start with an equilateral triangle here. We draw an altitude from the top vertex down to the bottom. So we draw a line down here that has a right angle at the bottom. We already know that that's 60 degrees. And then this is split perfectly in half, so that has to be 30 degrees. So this altitude does two special things to our triangle. It bisects the base, so that is equal to that. And it bisects the vertex angle. So that's what I showed up here. So our smallest side we usually call x, just that's how we usually start. And since this was an equilateral triangle and this side split in half, we know that the longest side, that hypotenuse of our 30, 60, 90 triangle, is 2 times x, because again, x is half of one of the sides, so the longest side would be 2x. Then this side, we could prove this using the Pythagorean theorem, but this is x times the square root of 3 is what this middle length side is. So the ratio of the side lengths of a 30, 60, 90 triangle is 1 to the square root of 3 to 2. With these special right triangles, we can find some of these pieces like we did with our 45, 45, 90 triangles. So with the 30, 60, 90, we can still find some of the same things. So we know the shortest side, which we had been calling x, is 21. So y will equal 21 times the square root of 3. Then x will equal 21 times 2, which 21 times 2 gives us 42. For number 2 here, this gives us 12 for this side right here. So that means x has to have a square root of 3 in it. If this side that normally has a square root of 3 in it doesn't, then it means x has to have a square root of 3 in it. So what times square root of 3 will get us 12? Well, for x, this will be 4 times square root 3. Because if we do 4 times square root 3 times another square root of 3, that will get us our 12. We know that y, in this case, is just x times 2, so y will equal 8 times square root of 3. Our final one is simpler, more like what we had for number 1. So we know the hypotenuse here is 10, so then x has to equal half of that hypotenuse, so x is 5. And y is going to equal x times the square root of 3, so y will equal 5 times square root 3. Thanks. I will see you all on Tuesday.